So here are your notes 5.3. Just finishing them off from today. Two main topics: be able to perform basic operations with polynomials. These basic operations are only going to include adding, subtracting, and multiplying. Division is going to be actually in the next section that we're going to be doing because it does take a little longer to explain how to divide two polynomials. Okay, so we're going to get polynomials and then we're going to perform those operations on them. After that, we're going to identify some special patterns we can use for products. So basically, when you multiply two polynomials, depending on what they look like, sometimes you can use a special pattern as a shortcut. But keep in mind that it only works sometimes. So if it doesn't meet the special pattern requirements, then you're going to have to go back to just the regular old ways I'm about to show you. All right, so let's get started. Adding and subtracting, very similar to each other. You're going to take one polynomial, so this is a trinomial, and we're subtracting another trinomial from it. Now, first off, you don't want to keep these parentheses on because in order to combine like terms, they need to not be part of a group. So we got to get these grouping symbols off of here. In this case, we can distribute. There's a number in front, a negative one here, and a positive one here. So first off, distribute. That way the parentheses are dropped. That way you can basically free up your terms so they can be combined. Okay, so right now you can think of there being a 1 here and a negative 1 here. The nice thing about the first one is that when you distribute a positive 1, it just ends up being the same. 8x cubed minus 3x squared minus 2x. And then you take this negative 1 and multiply it to that whole group, so negative 2x cubed plus 4x minus a 5. Now you're going to be looking for like terms. Go ahead and start with the highest exponent, which in this case would be your x cubed, which is this one and this one. So we're going to combine like terms. So an 8x cubed minus 2x cubed is a 6x cubed. You can cross them off afterwards. Normally I see students do that because it helps them keep track of which ones they've already combined versus the ones that they still need to combine. So since we combined those two and made a 6x cubed, now we're going to focus on the x squares. So there's a negative 3x squared, and there's no other x squared, so you just bring that one down. Let's go negative 3x squared. So we did the x cubes, just did the x squared. So now let's look for x to the first power, 4x to the first power, negative 2x to the first power. So we're going to combine this one with this one. Positive 4x with a negative 2x will make a positive 2x. Cross them off so you don't confuse them again. So everything's been combined except for that minus 5, and there's nothing to combine that with, so we just have a minus 5. And that's it. Can't really do much else with that because there's no other like terms. So that's how you subtract. Adding is actually the same way, except when you add, you're going to have one group plus another group, and when you distribute, you're going to be distributing two positive ones. And then over here, the sign's changed, but when you have a plus 1, it's not going to change. You basically just drop the parentheses. Big mistake a lot of people make here is that they distribute a negative 1. This will turn into negative 2x cubed, and they forget to distribute the negative 1 to the first term, the second term, and the third term. So you're going to make sure you switch all of those signs. All right, so that's how you add and subtract. We did this one in class. So let's go on to multiplying. So in order to multiply two polynomials, so this one is a binomial because we have two terms, the x, and this is technically a negative 3, multiplied by a trinomial. So 1, 2, 3 terms. So what we're going to do right now is, first off, identify the terms of each polynomial. So we just did that. That's a binomial times a trinomial. Now we're going to distribute each part of one polynomial to the other polynomial. Simplify your answers by combining like terms. So normally you're used to seeing just a binomial times a binomial. So two terms, and then doing probably a foiling method. This is similar to that, or you can use a box method. I'll go ahead and show both of those methods right now. But first off, we're going to take this x, which is part of the first group, and then distribute it to the second group, because it's that times the entire group. So you're going to get 3x cubed, because x times 3x squared is 3x cubed. Then we're going to do the x times the negative 2x, which is a negative 2x squared. And then x times negative 4 is a negative 4x. A little equal sign over here. All right, so that's my first distribution. Now, since it's a binomial, I also have to distribute this 3. It's actually a negative 3. So first I'm going to multiply these two. So negative 3 times a 3x squared is a negative 9x squared. Then I'm going to take the negative 3 and multiply it to the negative 2x because there's another term there. By the way, there's 3 terms here. That's why we're multiplying 3 times. So 3 times negative 2x, a positive 6x, and then negative 3 times a negative 4 is a positive 12. Now, as you can see, we distributed the x to all 3 terms on the second group. Then we took the second part of the first group and multiplied to all 3 terms of the second group also. So we distributed both of these that were part of the first group. Now we're done because there's no more terms to distribute. So now all we do is take a look at it and combine our like terms. So once again, start with the highest exponent on the variable, which is x cubed. There's no other x cubes. So we're just going to bring down to 3x cubed. Cross it off because you're done with it. Now go to squareds, negative 2x squared, negative 9x squared, which is negative 11x squared. Cross them off because you're done with them. Go to the negative 4x and the positive 6x. Opposite signs mean subtract, so 6 minus a 4 is a positive 2x. Combine those, and your 12 is just kind of left there by itself. And that's how you multiply. So yeah, just figure out how many terms. That on the first part, that'll tell you how many times you have to multiply. So this had a binomial, so I had to multiply twice. And then I had to basically do a double distribution. There's actually kind of like a middle step here. If I can get these to move. That's going to move kind of weird. All right, never mind. You can write this out as x times this group and then minus 3 times that group. That helps out students sometimes. I'm going to go ahead and do this one also, even though we just did a multiplication. So this one has a trinomial times a binomial. So 2 terms here. 2 ways you can do this. Since multiplication is commutative, meaning you can multiply it any which way you want. For example, 5 times 2 is the same thing as a 2 times a 5. So either way you multiply it's going to be fine. So why I'm bringing that up is because you can take the x squared and then multiply it to the 3x and the negative 5, and then take the 3x and then take that and multiply it to the 3x and the negative 5, and then take the negative 2 and multiply it to the 3x and the negative 5. So you got to do it 3 times. Or you can work backwards where you take these two and multiply it kind of backwards into this trinomial. Either way doesn't really matter which way you do this. Normally I like taking the smaller polynomial and multiply it into the bigger one, just because it's a little more organized about how many arrows you're actually drawing. So I'm going to do kind of like a reverse distribution here. So I'm going to take this 3x and multiply it to the negative 2, which is a negative 6x. Then the 3x times the 3x, which is a 9x squared. Then the 3x times the x squared, which is a 3x cubed. Okay, now I'm not done yet. I still got to take this negative 5 times a negative 2, which is a negative 10, nope, positive 10. Negative 5 times the 3x, which is a negative 15x. And negative 5 times the x squared, which is negative 5x squared. Nope, that's going over into this other problem. Okay. Now what we're going to do is combine like terms. Start with the highest exponent, which is the 3x cubed. There's no other 3x, no other x cubed, so x squared, negative 5x squared, positive 9x squared, which is a positive 4x squared. Negative 15x, negative 6x, which is a negative 21x, and then plus 10. There you go, no more like terms. And last one. So this one looks a little bit confusing just because there's 3 of them. But keep in mind, if you had 5 times 2 times 3, you can do the 5 times the 2 first and then the 2 times 3, or you can do the 2 times the 3 first and then multiply that by 5. You can multiply in any order you want. So you can do this group, this binomial times this binomial, and then just kind of ignore this one for now. Or we can do the back 2 and then ignore the front one for now. I can tell you this right now, if you multiply these 2, you'll get a trinomial, which will end up looking like this because the first 2 will turn into this, and then you still have this back one that you got to multiply. Oh, there's the bell, so I'll need to pause this for a little. Okay, so as I was saying that we can multiply this in any order that we want to. So basically you want to focus on two of the groups at a time and then bring the third later on. So what I'm going to do is I'm going to go ahead and multiply these back two groups. That way what I'll end up is a binomial and then these back two will make a trinomial. You don't have to do it in that order. You can multiply the front two groups and then do a backwards multiplication like we did here. So right now what I'm going to do is I'm not going to even look at this first one. So let's ignore it. So I'm going to just put a little box over it so that we can ignore it. And then just multiply these two binomials. So it's two terms times another two terms. So I'm going to take my x, multiply it to x, which is x squared. I'm distributing this x to both of those. That's going to be a plus of 3x. Middle part is a 4x. We're done with the first one, so now we're going to distribute this 4. 4 times x is a 4x. 4 times 3 is a 12. Simplify that out. We can combine these two as like terms, so it's going to be x squared plus 7x plus a 12. Okay? Now, we're not done, because all I did is I multiplied these two. I still have this in the mix, so it's going to be x minus 1 times this entire thing. So what I'm going to do is I'm just going to bring down this x minus 1 the whole time. This stuff is still in parentheses because it's still being multiplied. And we'll get x minus 1 times this trinomial now. So I have x minus 1 times these two. I multiplied those two, put them together. Now I have x minus 1 times this trinomial. Now I'm going to do that kind of like how I did over here. So I got two terms. Distribute both of them. So first x times x squared is x cubed. Put some equal signs in. X times 7x is a 7x squared. X times 12 is a 12x. I'm done distributing the x. Now I'm going to take this negative 1 and distribute that one. I'm going to do this in another color. Negative 1 times x squared is negative 1x squared. You don't have to put the 1 there, by the way. Negative 1 times 7x is a negative 7x. And negative 1 times 12 is negative 12. Now we're going to combine like terms. No other x cubes, so I'm just going to put x cubed. Okay, it's gone. Now look at your x squared. It's negative 7x squared. Minus 1x squared is a positive 6x squared. Okay, those are gone. 12x minus 7x is a positive 5x. And those are gone. Minus 12. And you're done. That's it. So that's how you would do it if they gave you three of them being multiplied at the same time. Focus on two at a time, then bring in that third group later on to multiply out. So it takes a few different steps there. All right, special patterns. If you guys recall special patterns, this is a perfect square trinomial. Front and back should be perfect squares. It's a perfect square that makes a 4x squared is a 2x. Perfect square that makes a 9 is a 3. Then you want to make sure that you can do 3 times 2x is a 6x. Double that, you get a negative 12x. So that is a pattern. And the pattern that comes up should look like this. So 2x minus a 3 squared. So we've done that in the past. So in the past we started here, we factored using a pattern to here. So now what we're going to do is we're going to start here, and then we can use a multiplication pattern to get right up to here. Okay, it's very similar. It's just working backwards from a pattern that we knew before. Same thing here. This is a difference of squares. It's a 5x. 6 times 6 is a 36, so this must be a 5x plus 6 with a 5x minus 6. So like I said on the previous one, we learned this pattern before. When we factored, we took that and said, okay, this is a fast way of factoring. Now we're going to have it separated into two polynomials being multiplied, and we're going to multiply them using a pattern to get it back up to there. So here's how it works. Special product patterns. Now keep in mind, you don't have to use these patterns, but they are helpful. First one is called the sum and difference patterns. If you have the sum and the difference, notice A and B are the same. You don't have to just double distribute. You can just say, okay, that's just going to be a squared minus b squared. That's a pattern that shows up mainly because when you do the middle part, b times a is ab. A times b is negative ab. That'll cancel out the middle term, so there won't be a middle term there. So that pattern comes up sometimes. Square of a binomial pattern. That's when you have a binomial and you square it. Basically, you take the first term inside of the group and square it. Take the back term inside of the group and square it, and then the middle term is made up of a times b and doubling that, and you get that. This is a reverse of the perfect square trinomial. So you don't have to take a plus b times another a plus b. In fact, or not factor, but FOIL it all out, you can actually just do this. Cube of a binomial. So a plus b squared, this is how you do a plus b cubed. A little bit of a pattern here that you can hopefully see. What you do is you take the first term and then cube it. Take the last term and cube it, and that's your front and your back. Now you're going to have two middle terms. Both of them are multiplied by 3. This comes from Pascal's triangle, but we're going over that a little bit later where these numbers kind of come into play. But the pattern ends up being this: 3 times a squared b plus 3 times ab squared. What I tell my students sometimes is think of it this way. Like if you wanted to make this fast way to memorize this, notice you have a cubed. Your next one is a squared. Your next one is an a, and then you don't end up with any a's on the last one. And then you start from the other end and you end up with a b cubed. And the next one up is a b squared. And the next one is a b. So it, and then the last one is nothing's there. And then you just throw some 3's in the front. Okay, and that's how you would cube a binomial. Let's see how much time's on here. All right, and there's actually a -1, 2. There's a pattern for the minus. All that happens with the negative is basically, there's two ways you can think of that about this. If you have a minus b, what you can do is the signs alternate. It'll be positive, negative, positive, negative. Or you can always think as the minus sign in here if you had a plus a negative b, and then you'll be able to do your signs from there. So you can either memorize two things with that or just always use this addition. Some teachers use different ones. I just say plus, and then if that's a minus b, I say a plus a negative b, and then you can figure out from there. All right, so let's go ahead and take a look at what this looks like. So first off, which pattern does this meet? Now, it's obviously not the sum and difference because that takes two groups. This is only one group being cubed. So that's going to be like this one. All right. So just to refresh your memories about the pattern, a plus b when it's being cubed is a cubed, a squared, a, and then no more a's. Then we start off with a b cubed, b squared, a b, and then no more b's, and throw some 3's on these middle terms. And there you go. That's the pattern that comes up anytime you cube a binomial. So my first objective here is to figure out what a and b are. So a here is a 5x. Our b here, I'm going to say it's a -4. Okay. So now all I'm going to do is I'm going to plug that into this form right here. All right. So I'm going to put a lot of blank spots here. Hopefully this doesn't look too confusing. So what this will be is blank spot cubed. That's my a cubed plus 3a squared and then a b plus 3a and then b squared plus b cubed. All right, so I'm going to throw in my numbers. So my a is a 5x. So this is a 5x. Anywhere there's supposed to be an a, I'm going to put a 5x in. A is a 5x. All right, and b is a -4. So this is a -4, -4, -4. All right, things keeps going away. So basically what I'm going to do now is I'm just going to simplify this thing. I'm going to cube this, square that, do all that nice good stuff. Hold on. All right, so we got a 5x cubed. That's 5x times 5x times 5x. 5 times 5 is 25. 25 is 125x cubed. So this first part right here is a 125x cubed. Okay. Now this next part is going to be a 5x squared. So what I'm going to do, I'm going to square it first. I'm going to get a 25x squared. Then I'm going to multiply that by a 3, and then times a -4. So 5 squared is a 25, times a 3 is a 75, times a -4 times -4 is going to be -300. And then don't forget the x squared. So it's going to be a -300x squared. That's this part right here. Multiplied all that together. Now next thing is I'm going to multiply all of this together. So I'm going to do my squareds first. So negative 4 squared is a 16. Then I'm going to multiply it by the 3 and the 5x. Doesn't have to be in any particular order, just multiply it in. So let's do the 5 first. So 16 times 5 is 80 times a 3 is 240, and then don't forget your x. So it's plus 240x. That's this part right here. And then, oh, whoops, messed up. Oh, no, I didn't. Negative 4 squared is a positive 16 times a positive 5 times a positive 3 is a positive. Now, negative 4 cubed is negative 4 times negative 4 times negative 4. So negative 4 times negative 4 is a positive 16, but then you're going to multiply it by another negative 4, and that's going to turn it back into a negative, and then that should be a negative 64. And that's it. Nothing combines after that. There's no like terms, so that's it. Now, alternatively, that's considered the shortcut, because the other way you would do this is 5x minus 4 cubed. So if you forget the quote-unquote pattern, what you could do, I'll do this in red, is 5x minus 4 times a 5x minus 4 times another 5x minus 4. So what you're going to do is you would just multiply this out triple, and you'll end up, you'll end up with something along the lines of this problem that we did before, where you'd have to multiply it out, then multiply it again, and then combine like terms and get down to here. As long as you remember the pattern, this is actually not that bad. It's actually about 2 steps, and then you're done. Okay, but you do have to remember the pattern. And this is just another pattern. But do notice that it's positive. This is a positive, then a negative, then a positive, then a negative. So the signs do alternate, because basically if you look at the negative sign, the exponent that it's being done to is alternating between evens and odds. So that turns it positives and negatives like that. Okay, you can try that one on your own. And that's it. So that should be enough for your homework tonight. I think your homework worksheet didn't have anything with patterns, but there will be something with patterns on the quiz. So I'll be doing that like maybe on a warm up or something like that. Okay, and that's all. All right, bye bye.